Welcome to EASYDONE Academy. Today we'll be looking at physics and our topic is wave. So in physics, when we talk about wave, what do we understand by a wave? We said that a wave is a disturbance that transfers energy progressively from point to point in a medium and that may take the form of an elastic deformation or a variation of pressure, electric or magnetic intensity, electric potential or temperature. In a nutshell, a wave is a disturbance or oscillation that travels through space-time. That is a wave. You can also say that a wave is a disturbance transmitted through intervening substances or space. That is what we mean by a wave. So also, let's look at wave motion. What is a wave motion? A wave motion is the motion through a medium of any quantity. That is wave motion. Wave motion is the motion through a medium of any quantity. What are the quantity? The quantity may include displacement, velocity, pressure, and electric or magnetic fields that varies with time. That is a wave motion. For example now, the circular ripples produced on the surface of a pool when a stone is dropped on the surface of water. When we say water, let's say a swimming pool, if you drop a stone on it, you will discover that there are some wave that will occur. That is ripples. That ripples that is being formed, it will be as if the water is expanding. That is a wave. And that's an example of a water wave. So on that, we can also look at a wave motion transfer energy from one point to another. From one point to what? Another. So on that, let's look at types of waves. Majorly, we have two types of waves, which are what? Mechanical waves and then electromagnetic waves. What are mechanical waves? So mechanical waves, these are waves that requires a material medium for their propagation or transmission. Before a mechanical wave can occur, there will be a material. There is going to be a medium. It will pass through a medium. For example now, example of mechanical wave is water wave. Before ripples can form on the surface of the water, there is going to be either a leaf dropping on it or a stone dipping on it. Even as small as a paper is, if it drop on the surface of the water, it will form at least a small ripples on the surface of the water. That is a water wave. So a water wave requires material medium for their propagation or transmission before it can occur. And examples of the water waves are what? Examples of mechanical waves: water waves, sound waves, wave in string, the string, tension, and then heartbeat. As you are, your heartbeat as it's going in and coming out, the way you are feeling, your pulse, the way you are feeling it is what? Is an example of a mechanical wave. And also, another one is electromagnetic waves. These are waves that do not require what? A material medium for its propagation. So that is the electromagnetic wave. Electromagnetic waves include what? Gamma rays, visible lights, X-rays, radio waves, television signal, ultraviolet radiation, microwaves, infrared radiation. These are the examples of what? Electromagnetic waves. So remember that a wave can be transverse or what? Longitudinal, depending on the direction of his oscillation. So what do you mean by that? We can now see the classification of waves. classification of waves. So under classification of waves, we are going to be having transverse waves and what? Longitudinal waves. So types of waves: mechanical waves and electromagnetic waves. Classification of waves: transverse waves and what? Longitudinal waves. What are transverse waves? A transverse wave is the one in which the elements of the medium move in a direction perpendicular to the direction of propagation. That's a transverse wave. So an example of a transverse wave is a wave on a taut string. So example of a transverse wave is this kind of a wave you will be seeing. This is an example of a transverse wave. So the down one here is called trough. The movement up is called crest. It's called what? Crest. And the distances between one crest to another crest, or from one trough to another trough, is called wavelength. It's called wavelength. And wavelength is denoted by lambda. In wave. And then the displacement, the upper displacement, is called amplitude. We are still going to look at the terminology terms in wave. So when we talk about transverse wave, these are waves that are what? Perpendicular to their propagation, or to the direction of their propagation. Also, when we talk about longitudinal wave is the one in which the elements of the medium move in a direction parallel to the direction of propagation. And examples of longitudinal wave is sound wave. So if you are hearing a music, you discover that by the time, if you hear it from afar, the more you are moving closer to where the drumming is, the more it sounds. So a longitudinal wave will form something like this. It will be compression. So here it started scatter somewhere, joining together, scatter, then joining together, scatter. These are longitudinal waves. This one that is together is called compression. Compression. And the one that is being scattered is called rarefaction. So these are the two classifications of what? Of wave. So if you have been asked now that types of wave, we have mechanical waves, and then longitudinal, and then electromagnetic waves. And then when we're being asked about classification of wave, we are going to be talking about transverse waves and then longitudinal waves. So you have to note that mechanical waves can be both transverse and longitudinal. Mechanical wave can be both transverse and longitudinal, but all electromagnetic waves are transverse waves. Don't forget about this. Terminology. So when you're hearing some terms in wave, so you'll be familiar with them. First one is what? Crest. As I've said, look at this diagram. This is an example of a wave. And then, so you agree with me that which type of wave is this? This is transverse wave. And we said that all electromagnetic waves are what? Transverse waves. So this may be X-ray, it may be gamma ray, it may be ultraviolet, it may be anything. Okay, so the crest. A crest is the highest point reached by a wave. So when it goes up, the highest point it reaches is your what? Is your crest. So it comes down. So the trough is the lowest point reached by wave. This is your crest, this is your trough. And then amplitude. Amplitude is the maximum displacement of a particle of the medium. Maximum displacement. So from here to here, that's your amplitude. Okay, then we talk about wavelength. We said the wavelength is the distance between two waves crest or two adjacent waves troughs. So from one trough to another, the distance between them is your what? Wavelength. From one crest to another, the distance between them is also your what? Your wavelength. Then also now look at what? Frequency. We said frequency is the number of crests that have passed a given point per unit time. Number of crests. Number of crests 1, 2, that is 2. So the number of crests that have passed a given point per unit of what? Per unit of time. That is your frequency. There's a difference between frequency and then period. So there's a relationship between frequency and period. By the time you get there, I'm going to show you. So period is what? Period is of a wave is the time interval required for the wave to travel one wavelength. So one wavelength of this from here to here, that's your period 1. So here, that's the first frequency. Another one, that's another frequency. So that is how to calculate between frequency and then period. Because there is a relationship between frequency and period, which is to say F is equals to N all over T. But if the number of the oscillation is just 1, that means F is equals to 1 all over T. So that is a wave terminology that we need to know to familiarize ourselves with. So by the time we go further in the explanation, we will know better. Equations for progressive wave. These are all the equations that is pertaining to wave motion. So whenever you see questions under equation of motion of a wave, just make sure the first thing is look at the parameters given to you. So this is A sine Wt minus Kx. Your A is your what? Amplitude of the wave. The sine, normal angle sine. The W is called wave frequency or angular frequency, also known as omega. The T is the time taken. The K is called wave number. And the X is the displacement of the horizontal axis given to you. So these are all the formulas you need to memorize for your own safety. So that by the time you see questions, you are going to know which one is related to this equation, then which equation am I going to make use of. And I've already said the omega is also 2 pi f. If I started proving how we got all this, time will not permit us. And your k is equals to 2 pi all over lambda or wavelength. Then for your phase angle, you can also use the formula kx to equals to phase angle. And remember that your phase angle can also be what? Phase 1 minus phase 2, depending on the question given to you. Then there's a relationship between speed of light or velocity of the wave and the frequency multiplied by wavelength. And also your t can be gotten by using x over v. So generally, y is equals to a sine Wt minus phase angle multiplied by x. So by the time we do our substitution method, in general we have y is equals to a sine 2 pi over t over big T minus x over lambda. Remember that this t one is talking about time taken and this one is talking about period. So remember all this by the time you are solving questions under motion. Everything you need about this have already been explained here, except in the further field when you're talking about light intensity, Doppler's effect, and many more. Okay. Properties of wave. The first thing to look at is transmission and what? And media. So waves usually move in a straight line, and in physics, so when we say something move in a straight line, it means it's what? Rectilinear. So you can say that the transmission of a wave, they are what? Rectilinearly through a transmission medium. And when you talk about media, you know, it can be air, it can be sound, it can be water. That is what? Transmission and media. Also, you now talk about absorption. So absorption, this occurs when a wave strikes a matter. The matter will absorb it. When a wave with that same natural frequency impinges upon an atom, then the electrons of that atom will be set into vibrational motion. If a wave of a given frequency strikes a material with electrons having the same vibrational frequencies, then those electrons will absorb the energy of the wave and transform it into vibrational motion. Of course, take for instance now, when we talk about absorption now, you have a torchlight. Okay, if you switch on a torchlight and then you direct that torchlight inside the glass, of course, you know that something will happen. Are you with me? It will reflect or refracted. That is under reflection. But absorption is that if the what's it called? The wave that is coming now, when it strikes a wall, like for example, this is a white material, it will reflect. But if you have an opaque material, so the wave will never go again. It will not reflect or refracted at the back. So therefore, it will be absorbed by the wall or by that material. So what we are talking about, it depends on the matter that the wave strike on. So if the matter that the wave strike on is opaque, it has more density than the wave particle, of course, there will be an absorption. It will absorb that wave automatically. Also, reflection. Any wave motion can be reflected. As I've said now, light waves and sound waves are reflected from a plane surface so that the angle of incidence is equal to the angle of what? Reflection. So under the reflection, we still have a reflection under optics as a topic on its own. Then we're talking about Snell's law, the first reflection law and the second reflection law. Also interference. So interference is the property of a wave in which two or more waves of the same frequency overlap. When two waves do what? Overlap themselves. That is what we mean as interference. And also refraction. So refraction is the change in velocity of the wave on entering a different medium. Of course, we know that light wave is reflected, likewise sound waves are also refracted. So that the light wave refracted, also sound waves also refracted. Of course, it is a plane and then a light wave enter here. This will be your incident. So it will be refracted. This will be your refracted ray. So it means that is why a light will be able to penetrate inside the water. If you have a drum, strike a drum here now, you'll be hearing from a very far place. At least, if not, the more closer you are to the drumming, the more you hear the sound. That it shows that it's refracted. So that is it. Also, we are talking about diffraction. When I talk about diffraction is the spreading out of waves when they pass through apertures or around obstacles. So if this wave cannot refracted, they cannot move further, of course, it will be diffracted back. It will turn back to where it is coming from. So this will be your diffracted angle or diversion angle. Also, talk about polarization. Polarization, a wave is polarized if it oscillates in one direction. The polarization of a transverse wave describes the direction of oscillation in the plane perpendicular to the direction of travel. Talk about dispersion. A wave undergoes dispersion when either the phase velocity or the group velocity depends on the wave frequency. And then now talk about velocity of wave. We'll talk about velocity of wave. So let's look at a transverse wave on a straight string. The velocity of a wave is given as v is equals to square root of t divided by m. So your t is the tension in the string and m is mass per unit length of the string. So this is the formula for calculating velocity of wave in the straight string. Also, sound waves in gas. Sound wave in gas. So the formula is v is equals to square root of gamma p all over rho. Don't be confused. The first p here, this is our velocity, this is our gamma. So the first p here is the pressure, but the one I call rho is not pressure. That one is called what? Density. That's density. That's density. So no difference between the two. And then our gamma, or the one that looks like a Y, is the ratio of the molar heat capacity of the gas. Molar heat capacity of the gas. So that is to tell you that you can also say that remember that our density is also mass over volume. That means if we represent this with our density, you can have v to be equals to what? Square root of y pv all over m, our mass. So depending on the question, as I've said, will determine if you are using this or you are using this. And remember that our peak pressure under the ideal gas equation is also equals to what? nRT, if you could remember. So if you also represent this nRT over m, where R is our universal gas constant per unit. So and our T is our absolute temperature. So if you now put it into the equation back, we are going to be having what? V to be equals to square root of gamma RT divided by M. So all depends on the question given to you will determine the formula you are going to use. And remember that since our gamma, the molar heat capacity, and the universal what's it called, the R, which is our universal gas constant, they are both constant. The Y and R, they are both constant. So you can say that the formula can give us what? V very root T. So you can have V is equals to M root T. So take note of all this when you are dealing with equation of a wave. Also, let's look at longitudinal waves in solid. Longitudinal waves in solid. So if you have to find the wave inside the solid particle, the formula is V very square root of E all over density, all over rho. Also, electromagnetic waves in solid, that will be V to be equals to square root of 1 all over mu multiplied by permeability. So this is the formula for electromagnetic wave in solid. So this one, this symbol is called permeability. Permeability from the word permeable. Permeability. So permeability, and this the one that looks like E is called permittivity. 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 So permeability meant that it was being permeable, it was being allowed for it to enter, and then permittivity, it gives it permission to enter into it. So in our next class, we'll be looking at different workings on the wave motion and how to solve them and find a solution to them. Don't forget, listen to this very well, because this is very wide topics and complex topics. So if once you understand all the definition, of course by the time we are solving the questions under it, you are going to understand it better, far more than just reading it by yourself without understanding what you are reading. Thanks.